Well, we've now finished the uprights. The bits that I've made are steel, so they're going to need a paint at some point, but we'll kick that can down the road a bit. Now we've finished the uprights, we can come to the rest of the front end, the meat and potatoes if you like, the wishbones. Now, I've been very fortunate enough that I've been able to get hold of a wishbone that pretty much suits my requirements secondhand. This comes from everybody's favourite used race car part salesman, but this I believe comes from a Route F3 from the 1980s. It has a 1/2 inch sized bush in the end there, so I can use 1/2 inch bolts either side. The problem I've got is these bushes, they're not all there, so I've had to, if I could just grab them, I've put them down somewhere. So I've had to buy some bushes, and although these nylon bushes fit inside here quite well, they're a little bit undersized. Obviously 1/2 inch is 12.7mm, these are 12mm, so I need to ream them out. Now I've put them in the lathe, I've tried to put them in the drill, and I can't quite get that extra material out. So if anyone knows how the best way to sort of ream these out, that'd be really useful for me to know, and then I can finally put this wishbone together. So yeah, I mean, this is pretty much bang on. This end here can be adjustable. It has a 19mm or 3/4 inch diameter a bush or something that needs to go into here. I think I might have cocked up a little bit with the 1/2 inch rose joint that I'm going to use. I probably should have gone 7/16, because getting a 1/2 inch sized 3/4 OD bush for these is proving quite hard, whereas 7/16 and smaller exists. For example, here is a 3/8 threaded bush with an OD of 3/4. I mean, it's perfect, it pops straight in there. So I'm probably going to have them made, unfortunately. So yeah, I'm going to see if I can find that and source that online. Bit frustrating, but we'll overcome that issue. So lower wishbones, I mean, these are really nice actually, and I got them cheaper than I could have ever made them for. And it's fabricated better than I can fabricate. And they've got these nice bits in here for passing brake lines through, because obviously this would be on a Formula car in the air. Not an issue for us, but still something to admire. It's not mine, unfortunately. Okay, so the next is the upper wishbone. Now I am going to fabricate the upper wishbone, and I've bent some tube. So I've got basically a piece of bent tube, a straight. I'm going to cut it so I can weld it together and make the wishbone. This is 16 gauge, so it's 22mm OD and 90mm ID, 3/4 inch. And these 3/8 threaded bushes will pop right into there like that, and I could just weld them in, job done. So that should be a fairly simple job. Some people say 16 gauge isn't enough, and it's not, and you know, it's just standard welded seam welded steel. It's not a drawn over mandrel tube, but it's the upper wishbone. It's not taking the same load as the lower one. I probably would reconsider maybe doing this for the lower one, but for the upper one I think it's fine. So I think that's my next task. I mean, there's other things I need to get on with, but I think this is my next task. Once I've got these wishbones, I can then populate it with suspension, a steering rack, and I can start like locating things, because I'm not fully set on the front end design for the structure and how everything's going to be mounted to everything. I've got to see where everything goes and where it fits, especially steering column around my feet and things like that. Time to crack on. I was also going to say lengths. How long are they? Well, the upper wishbone is going to be in line with the steering rack. So the steering rack I'm using is a mini steering rack. From the ball end of the mini rack to the other ball end of the mini rack, that's 610mm. The track of the car is 1400mm, so that's from centre of tyre to centre of tyre. So track of car 1400mm minus 2 half tyres, minus the steering rack dimension 610, so it's 1400 minus 610 minus 178, because I've got a 7-inch tyre, minus also, well, this is the upright, minus the width of that the upright extends out from the wheel, that's 50 millimeters. So we're aiming for a length of about 260 millimeters for this upper wishbone. So that is purely being dictated to us by the length of the rack and the width of the car, and obviously how it connects to the upright. The lower wishbone, I've designed that in software. I've written some software. I'm going to show you how I came up with that design. I've bought that in and it was roughly what I wanted, and then I've tweaked it in the software to make sure that that we've got the roll centers and camber gains that we think are reasonable.
Okay, well, back in the summer when I bought the car and I knew I was building it and I knew I was going to change the front end, I decided to write my own suspension geometry software. I don't recommend it. See Sense and just go to Racing Aspirations and use their software. It's actually designed by one of the drivers in the 750 Formula, and it's top drawer, it's ever evolving, it's way better than what I could code, and yeah, highly recommended. But I'm a stubborn git and I kind of needed an excuse to practice my coding skills, so I wrote my own, and this is it. So you know, you can see here I've got my upright height, arm length, chassis points, all the crap I need. I'm going to show you what a low cost geometry looks like. I should have one here. There we go. That's kind of what a low cost looks like, and you can see, you know, it's not bad on camber gain, and my software also calculates roll centers as well. So you can see they roll center for the car, which is this red line down here, moves around quite a lot on height, but worst is it actually moves quite a lot on bump and roll as well. I've got a sort of zoomed up version down there where you can see where the roll center is. If I drop it down to 40 millimeters bump, yeah, it moves quite a bit. And you know, the low cost is well known for having really not great bump control, but anyway, that's a low cost, and using this software I've managed to come up with what I think is great for our car, or my car. So I've got a upright length of 235 mil, and I've got the upper arm at 260 millimeter, and my lower arm is 413 millimeter. Obviously that's a bought-in piece now, that lower arm, and the upper is 260 as well, as mentioned before. So that's divided by the length of the steering rack, which is shown here. It's divided by the length of you know, the upright, how much that comes in, which is about 50 mil, and we've also got the width of the tyre as well, half width of the tyre based on you know, the track of the car and where we want the wheels to be. Yeah, you can see if we go up, you know, 70 mil bump, which is way more than where we're going to go. Probably going to ever see 50 maximum. The wheel camber is 1.56 there at 51 mils bump. If we go down to 0, the static camber there is minus 0.4. So 2 degree camber gain between max and minimum. If we go 40 mil the other way, it's minus 2.6. So another sort of 2.2 gain. So it's okay, acceptable. We could probably do better on the camber gain, but I've really focused on getting a really good roll center. So, you know, the roll center doesn't move around too much on height. I mean, I'm going all the way down to, you know, 71 mil bump up to, you know, 70 mil droop. So that's way bigger than we're ever going to see. We're only going to ever see stuff in this range. But if we look at, you know, being up high, that roll center's really nicely static. If we drop down to zero bump, go up to 0. If we go to 0, again, nice and static, not too much movement at all. And then if we go down to, you know, minus 40, minus 41, which is pretty much probably the maximum bump we'll see, because the car has a 40 mil ride height. Might be a bit more depending on how we set it, but again, not massive amounts of movement in the roll center. So that's really what I focused on, and getting a really good roll center, really static roll center. is going to be really key for you know, a predictable car.